This is Unit 1 Outcome 5, and the first question asks us to calculate the length of the minor arc RS. Now an arc is part of the circumference. So the first thing to do here is calculate the circumference, which is pi times the diameter. Remember, you don't get given this in the exam. Now the diameter is twice the radius, so it's 180. Our radius is 90, so our diameter would be 180. And pi times 180 is 565.487, and that would give us the length all the way around the circle. And we need to check for just a fraction of that. And the fraction that we want is 80 out of a possible 360. So when you're putting that in your calculator, you're keeping the answer in that you had for the circumference, multiplying by 80 and dividing by 360. And that is 125.66. We need to do decimal places. And I'm just going to double check the question. It's not specifying number of significant figures or anything, so that's question 1. Now question 2 asks us to calculate the area of the major sector of the circle with a radius of 5 metres. Now the area of the sector is a fraction of the area of the whole circle, and the area of a circle is pi r squared. So we're going to calculate that first. Pi times 5 squared, which is 78.54, and we want a part of the sector, and it's a fraction of the total area. Now it asks for the major sector, which means it's this bigger area here rather than the small part that's been cut out there. So we need to work out the angle. There's 360 altogether, 50 in the minor arc, which leaves us 310 in the major sector. So I've got 310 out of a possible 360, and I'm multiplying by my 78.54. which is 67.63 square metres. Now, we're given a diagram which shows a kite, PQRS, and a circle where Q is the centre. PS is a tangent to the circle at P, and RS is a tangent to the circle at R. Now, what this means when PS is a tangent to the circle, if the tangent meets the radius at the circumference, we know that's a right angle. So the same will happen on R. That's one of the rules that we know about circles. So given that angle PQR is 120, state the size of angle QRS. Well, QRS, as we know, it's where the tangent meets the radius, so it is a right angle, which means it's 90 degrees. No working to be shown, we just know it's 90 degrees. B, we're asked to find the size of the angle PSR. That's this angle here, it's the only one that's missing. Now it's a quadrilateral, it's a kite, so all the angles will add up to 360 degrees. We've got 90 here, 120 and 90 here, so we're going to just add those up. Which gives us 300 degrees. The whole quadrilateral needs to add up to 360. So the missing angle is 60 degrees. Okay, now the last question shows us a triangle, PQR, inscribed in a semicircle with a diameter of PQ. Now, we did this experiment in class. If you have a triangle inside the circle, where one side of the triangle is in diameter, that side is the hypotenuse, and the opposite side is a right angle. So we know the angle PRQ is 90 degrees. We're also told that RPQ, which is this one here, is 45 degrees, and we're asked to find the size of the shaded angle, which is the third angle. So I've used up 190 plus 45, which is 135. It's going to be 180 degrees in total, so I'll subtract that, and the missing angle is 45 degrees. And that's the end of outcome 5.